In this video, we're going to take a look at dividing complex numbers. So I've got two complex numbers here to start with, z and x, and they're expressed as follows. And we're asked to find z divided by x. So to divide complex numbers, we simply use the complex conjugate. Now we need to give it in this form here, a plus bi, where a and b are constants to be found. And maybe instead of constants, it should say rational numbers, but it doesn't really matter just for this one example here. So let's set it up here as they presented, so z over x. So that's going to be z, which is 1 plus I, over x, which is 3 minus I. Okay, so if we set it up like that. Now, we're dividing complex numbers here, so like we said, we need to use the complex conjugate. Now, what we do is we multiply the numerator and the denominator here by the complex conjugate of the denominator. So that all sounds a bit confusing. All I'm simply doing then is I'm going to times top and bottom here by 3 plus I, because the denominator is x, which is 3 minus I. So in that case, the complex conjugate of the denominator, so that's going to be x, the little asterisk here, the little star, that will be 3 plus I. Okay, so in that case, we times top and bottom here by 3 plus I. Like so. So what I need to do now is evaluate these products. So I've got 1 plus I times 3 plus I. Okay, do the same with the denominator here. We've got 3 minus I times by 3 plus I. So let's evaluate the product here in the numerator first. So I'm just going to use FOIL, but any method to expand double brackets is absolutely fine. So we've got 1 times 3, which will give me 3. We've then got 1 times I, which will give me I. We've then got I times 3, which will give me 3i. And finally, we've got I times I, which will give me I squared. So plus I squared. So that's my numerator. We'll come back in a moment and actually simplify this once we've evaluated the product in the denominator. So the product in the denominator here, these two brackets, is quite straightforward to expand. And the reason for that is because we've actually got the difference of two squares here. So that's the whole reason we times through by the complex conjugate, because it eliminates I in the denominator here. Okay, so all I need to do is do 3 times 3, which will give me 9. And then we do minus I times I, giving me minus I squared. Okay, so how do we simplify the numerator and the denominator here? Well, we need to know what I squared is equal to. So I squared, which we do know what that's equal to, is minus 1. So here I've got 3 minus 1, so that would give me 2. And then I've got I plus 3i, giving me 4i. So we get 2 plus 4i in the numerator. For my denominator now, we've got 9 minus I squared. So if I squared is minus 1, 9 minus minus 1 is the same as 9 plus 1, giving me 10 there. So in this case now, we can simply divide top and bottom here by 2. So I'm going to get 1 plus 2i over 5, like so. And we want to write in this form here a plus bi, where a and b are constants to be found. So in that case, if we write in this form here, we're going to get a fifth plus 2/5 of I. Okay, so clearly a in this case is 1/5 and b is 2/5. So there we have it. So that's our solution to the first example. Let's work through another example together here, and then to finish with, there's a practice question for you to have a go at. So we've got a here, which is minus 1 plus 2i. And then we've got ab, which is equal to 3 plus 4i. So we're asked to find b, and we want to give it in this form here. So where do we begin here? Well, I've got this product, ab, which is equal to 3 plus 4i. Now, if we know one of these complex numbers, say a here is minus 1 plus 2i, then I can work out the other complex number. So in that case, we can write this as b is equal to 3 plus 4i divided by a. So all I've done here is I've took this equation and I've divided both sides of the equation by a. Okay. Now we know what a is equal to. That's minus 1 plus 2i. So b is equal to 3 plus 4i divided by a, which is minus 1 plus 2i. So what we need to do now is evaluate this division here. So I need to times through my numerator and my denominator here by the complex conjugate of the denominator. So we're going to times through by minus 1 minus 2i in the numerator And then similarly for the denominator here, minus 1 minus 2i. Okay, so like I said, we're going to get a product here in the numerator and the denominator. So for the numerator, we get 3 plus 4i times minus 1 minus 2i. And for my denominator here, we're going to get minus 1 plus 2i times minus 1 minus 2i. Okay, so just taking care here with our signs now. So let's evaluate the product of the numerator first. So 3 times minus 1 would give me minus 3. We've then got 3 times minus 2i, so that will give me minus 6i. We've got 4i times minus 1, so that will give me minus 4i. And then finally, we've got 4i times minus 2i, so that will give me minus 8i squared. Okay, like so. So that's our numerator. Let's evaluate the product here with the denominator now. And again, this is the difference of two squares. So all I need to do here is minus 1 times minus 1. So that will give me 1. And then we need to do 2i times minus 2i. So in that case, I'm going to get minus 4i squared. So minus 4i squared. So let's simplify the numerator first, and then we'll simplify the denominator. So in this case, we've got I squared here, so straight away I squared we know is minus 1. So if I've got minus 8 lots of minus 1, that's the same as plus 8. So in the numerator here, we've got minus 3 plus 8, so that would give me 5. So we get 5 there. I've then got minus 6i minus 4i, so that would give me minus 10i. Okay, so 5 minus 10i, so that's our numerator. For the denominator now, we've got 1 minus 4i squared. So again, we've got this I squared here, which we know is minus 1. So minus 4 lots of minus 1 is the same as 1 plus 4. So we get 5 here in the denominator. Now with this case here, we've got 5 minus 10i over 5. We want to give the answer here for b in this form. So x plus iy, where x and y are real numbers to be found. So in this case, what I'm going to get here is 5 over 5, which would give me 1. And then we get minus 10i over 5, which would give me minus 2i. So we get 1 minus 2i there for b. So let's just write that over here. So therefore, b is equal to 1 minus 2i. Now, clearly we could verify this solution by evaluating this product here. So if I take a minus 1 plus 2i and I times it by 1 minus 2i, then we should get 3 plus 4i. And you can verify that it does work. So if you do want to take the time out to check that, then be sure to do that. Okay. But that's our solution. So this is what you should get for this example. And then there's one practice question here for you to have a go at. So what I do here now is just pause the video, have a quick go at this question here, and then we'll take a look in a moment at what you should have got. So I said take a look at what you should have got. It is a show that question, so we know what we should get, but let's take a look now at how you should have got to this solution. So we're asked to show that 3 plus I divided by 2 minus I is equal to 1 plus I. So we're doing division here. So we know that we times through by the complex conjugate of the denominator. So we take 3 plus I and we times it by the complex conjugate of our denominator. So that's going to be 2 plus I. Like so. Okay. Do the same now with the denominator. So that's going to be 2 minus I. We times that by 2 plus I. Okay. Like so. So here, let's evaluate the products now. If we start with the numerator, I've got 3 times 2, which gives me 6. We've then got 3 times I, which gives me 3i. We've then got I times 2, which gives me 2i. And finally here, we've got I times I, giving me plus I squared. So that's our numerator. If we take a look at the denominator now, I've got 2 times 2, which gives me 4. So because, again, this is the difference of two squares, we only need to do 2 times 2. So we get 4. And then minus I times I, giving me minus I squared. So remember, I squared is equal to minus 1. So we've got 6 here minus 1, which gives me 5. And then I've got 3i plus 2i, giving me plus 5i. Okay, so that's our numerator. If we look at the denominator now, we've got 4 minus I squared, where I squared is equal to minus 1. So minus 1 is the same as plus 1. So we get 4 plus 1, giving us 5. And then here, if we just simplify, I've got 5 plus 5i over 5. So dividing top and bottom by 5 here, we get 1 plus I, which would be over 1, which is the same as 1 plus I, which is what we wanted to show here, so as required. Okay. And there we have it. So that's our solution. Happy days. Okay. So that actually brings us to the end of this video. In the next video, we're going to take a look at solving quadratic equations that have imaginary or complex solutions.